To resolve a vector into its x and y components, there's essentially two steps to follow. First, draw a right triangle from the vector, and second, use sine theta and cosine theta to find the magnitudes of each component. So here we have a vector, 2.5 newtons, north 50 degrees west. So I'm going to take a straight edge and I'm going to approximate that vector. It doesn't need to be perfect because this is really just to help us visualize. Okay, so this vector right here is 2.5 newtons and it's roughly north 50 degrees west. So draw the right triangle from this vector. One tip I would recommend doing is draw the triangle in the order of the directions given. So in this case I'm going to draw the north vector first, and then I'm going to draw the west vector second. Why this order? I'll show you in a few minutes. Now what we've drawn here is the x and y components of this vector. This is the Fy, the y component of the force, and this is the Fx, the x component of the force. So now we're on to our second step using sine theta and cosine theta. The thing is, what is theta? Well, because we went north and then west, we know that down here is going to be our theta. And theta is 50 degrees. So long as you go in the order given, the theta will be at the beginning of the vector. Now we use sine and cosine theta to find the magnitudes of each component. So in other words, we need to find fx and we need to find fy. Now I always take a moment when we have our theta to identify the opposite and adjacent sides. So since theta is down here, this is our opposite side and this is our adjacent side. This of course is the hypotenuse because right here is a 90-degree angle. In this case, fx ends up being our opposite side. That's not always going to be the case. You really have to pay attention here. Sometimes the x vector will be adjacent and sometimes it will be opposite. It just depends on the situation. So in this case, we're going to try to find the opposite side, which is going to be the fx. But we don't know what it is yet. We know that the hypotenuse is 2.5 newtons, and we know that theta is 50 degrees. So we have opposite and hypotenuse and theta, so this is a sine problem. Now here we substitute. We're going to have to multiply both sides by 2.5n. Those will cancel out. And so here we get 2.5, I'm going to use parentheses. And so it turns out that 1.9 newtons is our Fx. 1.9 newtons. And for the adjacent side, which is going to be our Fy, we have hypotenuse, the angle, theta, and we want to find the adjacent. So we will use cosine, ca. So here, might as well extend these lines. We'll have to again multiply by 2.5 newtons, decimal in there, 2.5. The 2.5 newtons will cancel out here. Once again, we get 2.5 newtons times cosine of 50 degrees is our Fy. And when we calculate that, So our force is 1.6 newtons. Now it's not quite complete because force is a vector and we need to make sure we understand what direction this is. In the y direction it's pointing up, which indicates it's to the north. For our fx it's going to be to the left, which indicates it's to the west. These should not be any different from the two original directions. They carry over. So we need to make sure that we are complete in our answer. And since we are now complete in our answer, we can put a box around it and call it done. What we should do is make sure this makes sense. If we have 2.5 newtons in the northwestern direction, it does make sense that in the north direction is about 1.6 newtons and in the western direction is 1.9 newtons. So it looks like we did a good job here and we're going to call it